And we're back. This is Rob Crawford of Ixia Federal, and this is part two of our a little series on using BPSVAR, breaking point, setting up a client and a server where the server returns a token back to the client, and the client then uses that token in the following message. So we've created our superflows, one client sim and one server sim. And so I'm going to go the next step, and our next step is going to be creating a network neighborhood. This will be specifically for this client to server test, port to port, between two ports, no actual physical server. I'm going to call the new network neighborhood, let's see, how about we'll start with interface. We need two of these, and one for each port, and endpoints. IPv4 external hosts, I want one of these, and IPv4 static hosts. I need two of these. So we'll set both of these up to point at the two ports. And I'm going to call this one client and this one server. Well, server. And let's go with 10. This is the client address. Whoops, 100. And then the server will be 1, 10.10.10.1. And you can set these up as the opposing addresses and use one of each. Don't forget the net mask. So I'll go ahead and set these up. .24, and we're done. Now, up here, I'm going to set up a server, and this is just because when you set up client sims, you've got to have a server, even if it's really another port on the breaking point. And so this will also be 10.10.10.100, whoops, 1. And just in case what I just said didn't really make sense, I want to save this and show you when we create the new test. So let's get this replaced with that. And now I'm going to create client sims. I'll set up 2. And each one will have one of the two superflows that we've created. I'll leave that as client sim. I'll get rid of these and replace them with, this is my new external server, and this is my client. So I'm going to drop these way off. because I don't want to have a huge amount of data to go through. I just want to find the cookie in the pcap file. All right, let's do a search for the superflow we're going to use in this client sim, and there it is. This is the one we edited in the previous video. And then return, and we'll hit up the server sim, and I will search for the same thing. We'll do video cookie and check to make sure, change these. I edited probably edited out a little step or two here, but just went back and also changed these guys. And on this component tag section, you don't have to have a client tag, but you do have to have a server tag. This server is the actual server that's port 2, the interface. And server dub was the external server, which is this is just a stub essentially. I'm going to return, and I have client traffic, server traffic, both set up. The superflows were created in the previous video. I've got a green check mark. I've got nice small numbers here, and I'm going to go ahead and do a save and run, and we're going to pause until the test is done. Okay, well, the test is completed. Got a lot more attempts than I did when I was playing with this earlier today, but we'll see if I must have set something differently. And don't worry about if you do have some failures. We're basically just looking to see this token get passed from the server to the client and back to the server. I'm going to click on that button, hit packet export. I forgot to mention this already needed to be checked before you ran the test. Enable packet capture, that is. I'm just going to look at the client side. Both of these should be the same. And I'm going to hit export, and we're going to look at this using Chrome, by the way. I'll hit open, and here it comes. So I got a little setup happening already, and there's a get. And as you can see, no indication of any cookies anywhere. And let's see, there's my get. I'm going to drop down and do 200 OK, and this is sending the cookie. There it is, in fact. Last visit equals 123. And for the piece de resistance, okay, I'm going to have to re-record this. Now I'm looking at the get command, and my get command has last visit equals 1234. So this came from the the client. The client, nothing in the client superflow has this information. What we have in the client superflow was last visit equals, or last visit equals, and then you set it, and then you use regular expression to pick up the 1234. So last visit, it knows ahead of time that last visit is going to be the name that it's looking for. Now we don't have to know the name of the cookie. We can pick up all of this. We can change that superflow to just a slight change to that superflow, and we'll be able to see anything, no matter what the name is. I can make it Rob equals 1234, and we'll find that. So that will be the next and last step of our little experiment here. But that's our get command, and as you probably know, you can do things like this with Wireshark do follow TCP stream. You can do the same with SSL, by the way. And here's what we just looked at, but in a nice little package for us. Um, so if you do have a lot of traffic and you need to look at one particular set of client server instructions, then you look at it this way. And well, isn't that special? No, let's see, this is my 200 OK. There it is. Okay, there's my 200 OK with the last visit. That's what we just looked at. And that's coming from the server, and then coming from the client. We drop down here, and there's the cookie being sent back to the server. The reason why we do this, by the way, is so that you're like when you connect up to a bank with your web browser, you've got an HTTPS SSL connection, and no one's going to break into that. But malware sitting on your laptop can execute instructions through your web browser and go in and transfer money from one bank account to another. In fact, if you have a second web browser open and it's connected to a website that happens to have malware running in the background, that malware can actually reach out through that connection into your laptop, back out through this web browser, and and make changes to your bank account. And you won't notice it. I mean, unless you happen to look in the right place, but you won't see it happening as it happens. And so banks will send a token, and no one can query the web browser as to what the token is. So once you send a token, that web browser will use it each time it communicates back with that website. And so you'd never have to worry about malware on the laptop reaching out through the web browser and making changes to your bank account. The bank's going to completely ignore those messages because they won't have the token. Real tokens are giant random numbers. Just a little extra flavor. I'm going to do one more video that uses more regular expressions to capture both the name and the number of the cookie, and that is next in part 3.